Okay, hello guys. Welcome to our next class. And today in Blender, we're going to be simulating fluid. We're going to be simulating fluid, and we're going to be testing this out um, using two types of simulation. We're going to simulate a swimming pool. Okay, just a fluid in a swimming pool kind of container, and we're going to be pouring a fluid in a glass cup. All right, so let's get to it. So I'm just going to open up a scene I've prepared for it from our last class. So our last class, we looked at rigid body physics, where we dropped this into a container like this. So I'm just going to click on this and expand this container. Or if you want this grid not to distract you, you can click here and go to floor and click it so it goes off. All right. Okay, so if you want this ones to go as well, click on this and remove the axis X and Y so you can see it. Fantastic. All right, so we're going to expand this to be like a pool kind of thing, and we'll click on this to drag it, and click here to drag it out here. Something just not too much. Okay, click on one to see, and take this way up. All right, take it way up. Now if you're wondering why my own is scaling from down and not from the center, in case yours is scaling from up, you see my origin point is set to be here. Okay, so how do I do that? Let me reset this so that in case set origin to geometry. So in case if your origin is at the center and I press what I'm trying to scale it up, it scales from the center, right? Up and down, and you might not want that. Press escape. So you just have to click on the body here, click on this. So this will make your cursor to be on top of the surface. Then go to objects and set origin to 3D cursor. All right, so that has brought your cursor to the surface. So if you press 1 and you now decide to scale by taking it up, it will scale it while your surface is still there. All right, since your surface has thickness, your cursor is on top of the top surface, not the bottom one. So you can just go ahead and click on this, click here to hide it, then go here and click on the lower surface and set your origin to the 3D cursor. Okay, oh sorry, click on this, set your origin to 3D cursor. All right, fantastic. So you can on your plane again. Now when you try to scale it up, it takes it from there, and that's how I did mine. Okay, so you can make it a little bit higher like this, like a deep pool. Go to wireframe, see that? Good. Now what we are trying to simulate in Blender, by the way, we're going to make this bottle fall into the pool as well. We all love such things, right? So we're going to take this up and make it fall into the pool. So while simulating fluid, you need a domain, and you need something to actually put the fluid here. There are two kinds of simulations. One is when you just have the water that will sit here and drop in and become a fluid, and the other one is like a tap that has to impute water in. So for the pool, we're just going to get something that would form as water here. And how do we do that? We'll press Shift A, go to mesh, go to cube, add a cube. All right, take the cube up and make it to be roughly the shape of the swimming pool, but don't touch the edges. Let it not touch the edges. Okay, let it be close to the edges but not touch the edges. Okay, because that would cause problems. There will be consequences if it touches the edges. So just scale it to X and Y like that. Doesn't touch the edges. Bring it close to the edge but don't touch the edge, just like that. And you can look at it from one orthographic mode, go to wireframe and make sure it's not touching the edges, then take it up, way up, and bring it down. All right, okay, that's cool. Go to 3, the other side, and 3 shows the other side of the view. Bring it a little bit here, outside the edges, and that's good. And just scale it down. Let's not be too high. Bring it down. Okay. Scale it down a little bit. So this is going to be our water in the pool. Okay, this will be our water in the pool. So because this is going to dissolve and become a water, so that's what we're doing. All right, it's going to dissolve and become water. So we have gotten the water object. Now, selecting this water object, we are going to go to objects, go to quick effects, and go to quick liquid. Okay, so when you click on this, Blender automatically creates your liquid simulation. All right, now there are three parts of this liquid simulation that you need to know, and one is the object. The domain object is the general box surrounding it. Let me press 1, or let's press 3. This is the domain object. This is where the liquid simulation would calculate itself. Nothing happens outside this object. Nothing is simulated outside this box, because simulations is a very heavy thing for computers to calculate. So you can't calculate it for a whole scene. It has to limit itself to a particular box. All right, so your CPU does not crash, and your computer does not get toasted. So this is the domain object. So we're going to increase it to accommodate more areas, because nothing is simulated outside it. So in case there are splashes of liquid, you're going to, and be careful how you increase it, because the more you increase it, the more your system has to calculate for for things happening around it. Okay, so take it up in case this bottle will drop here, in case there's a splash and all. Well, let me just take it up. I don't think there should be so much splash, because this water object was not high up here. If not, it will drop in and splash. So it's close to the body, so there won't be much splash. We'll have to take it up here. Yeah, so at the base, sits at the base of the container as well. And yeah, the sides as well, take it closely. Okay, so it doesn't simulate areas that you don't need. All right. Okay, let me take this up a little bit so it splashes, so you can appreciate the splashing. I'll take it up a little. Okay, this is the liquid itself, so I'll take it up a little, and it would splash while it dumps down. It's when it simulates to dump down and hit the whatever. So this is the domain object. This is where the whole thing is calculated. Now this center, this one is the liquid. The one we created, the box, is what is actually the liquid itself. And then this one, the third one, is going to be what will come here. We'll go to fluid. All right, I have to, sorry, let me close all these things so you know. So there are three, like I said, there are three areas to a fluid simulation. This is the domain object that covers everything, and this is the fluid. Okay, this is the fluid. By clicking quick fluid, it gives itself a flow object, and is a liquid. Okay, flow type is liquid. All right, we'll look at smoke and fire at the next ones, but this is liquid. And the flow behavior is a geometry. All right, we have inflow, outflow, and geometry. Inflow is what we are simulating for tap. You are pouring water into the scene. Geometry is that the geometry itself, the box itself, becomes the liquid. All right, outflow is that this takes out water from the scene. All right, so whereas this one is the third element, which is we have to click on fluid, and the fluid type will change it, not domain, not flow, but effector. So effector is going to be like a colliding object. It's going to be a collision object or a guide, but mostly we'll be using collision. This is what's going to make this liquid collide with the edges of the pool. Okay, the container. What? Okay, so the same thing, this is going to fall into the water, so it has to collide with the water as well, so it doesn't fall through. Click on fluid, click on by the way, this is the physics. Okay, this physics. Let me close on rigid body. It has rigid body on it. So click on fluid, change this from this to effector. All right, effector, and it has to be a collision, so it's colliding. The same thing with the container, all parts of the fluid should collide. All right, click on fluid, click on effector, and it's a collision. Then the cover as well, click on fluid, click on effector, and it's a collision. Okay, so once it falls in, it collides. All right, now we are going to be seeing this in wireframe. Now when we come to the domain object, this is where the calculations are made. Well, so look here, this is the quality of your fluid. 32 is the lowest quality. We can make it to be like let's say 128, just for the sake of the tutorial. All right, 128, click on that and you see your fluid. Okay, by the way, once we have adjusted this scale, press Ctrl A and apply rotation and scale. All right, so that the fluid is calculated properly. If you adjust anything on the scale, apply it. All right, so that it's calculated properly. All right, even the domain, click Ctrl A, apply scale. We didn't rotate, apply scale. Okay, so it's calculated properly. All right, even this one, Ctrl A, apply scale. Everything should be applied so that it's done properly. All right, so while clicking on this, the settings you need for your fluid simulation is in your domain. So you change the division to 128. You can see it's simulating more particles. Okay, fluid simulations are actually particles, so it makes it more high resolution. And now when we play this, it's going to the one of the settings again we'll have to look at is in the fluid cache, right? In the fluid cache. So change this to a place where you can see in your system. There's nothing wrong where it is, but sometimes the cache can actually be saved somewhere you don't want it to be saved. So go to where you want it to be saved, create a folder there and save it there. Mine, I've already created something for it already, so save it there and press accept, so that you can always go back and delete it there. Then change the start and frame, the start and end frame to like 100. Click 100. All right, because your frame here should be like 100. You shouldn't, unless you want it to simulate for up to 250 frames. Okay, then leave it at replay. If you leave it at replay, you can play it here and watch it simulate. All right, it can be slower, but just click on resumable so that you can pause it anytime and watch if it's doing what you ask it to do, and continue as well. If you don't do this, anytime you press pause, it has stopped and you have to start afresh. So if I press play here now, you see the particles will start to simulate and start to fall inside. Okay, starts to fall inside. All right, it starts to fall down, inside this, and to interact with this pool container. Okay, so right now you are seeing it as a particle. So I'm going to stop this. Let me stop this, and just for the sake of tutorial, let me make it at 64 resolution. All right, it's quite high resolution. I'm going to make it 64. Like if I play now, you see it's went a little, it's going down, but I want to make it 64 so we can all follow through and not just get stay here watching it. So I'll press 3 to see the particles there, and yeah, so once I press play, it starts to simulate. You see how the particles are falling, and it is interacting very well with the fluid container. Okay, all right, so it's interacting very well with it. So this is the fluid. Okay, all right, so it's working well. So in that case, we can see the particles are working. So let us give the particle a mesh. All right, you have to give it a mesh so you can see it like an actual fluid, not as particles. So click on mesh and it actually becomes a mesh. Okay, you can come out of here and click on this surface to see it. Now when we press play to simulate, you can see it starts to fall in. See, So the domain actually forms the liquid itself. Okay, it forms the liquid itself and it drops into here. You see it interacts here, interacts with the surface here. Okay, and you can come here and delete and put off the cube. Like if you're seeing the cube, if you don't want to see it, you can press this to hide it while you just see the domain object. You can see it's too full, right? I think we made the cube to be too much. We're supposed to have given it more space, so it's probably is going to spill out here, and that's how you make a water simulation. Okay, that's how you make a water simulation, and it's actually baking right now, and yeah, so you can see it's interacting. It can get so full that it starts to drop. It starts to drop. Okay, remember our quality of simulation is just 64. The more you increase this resolution, the more better the fluid looks. Okay, this is just a low resolution for us to see for tutorial. Okay, so let's just stop it here first and go back and play it again. You see it happens faster, it drops in like that, and that is your water. Okay, all right, so we can see the water is actually much. So we can come back here, go down here, and because we're actually replaying this, there's no way to cancel the simulation than to open back this cache file, select all this, press delete to delete everything, and press accept. So everything is no longer simulated anymore. If you press play again, it starts to simulate. So what we're going to do is we are going to let's put back this cube, and we're going to change this. We're going to actually do a physics of this. So let's go ahead and press this to just stop the simulation first, so it doesn't simulate anything. The domain object does not simulate anything. Oh, we see the domain needs to even cover this whole area, so we need it to cover it. Okay, press this to make sure it covers it. All right, it covers all the area. Remember, whatever is not inside this box is not simulated, so it covers all this and covers everywhere. That's fine. Okay, that's fine. Now let's make this continue to drop in. Okay, let's make it fall in. Remember, it's a collision. Press 3. So we're going to remember our last tutorial, we made it a rigid body, right, and made it animated. Now we want this to follow the same tutorial I used to do the rigid body animation. So we're going to leave it animated, saying computer, let us control our motion ourselves. The letter will give you control later. So we're saying between 1 and 5. All right, let's add this. Let's make a keyframe for the animation and press K and say location and rotation. Add a keyframe for it and make this automatic as well. Then by 5, we want this to actually okay, let's take this up. So we'll give it more momentum like the last time. And now by 5, we want this to dump itself right here just before it gets to the water. I want it to like rotate it like this up to here. I'll stop there, right? And I'll add another keyframe there. Then at the number 6, would say, okay, computer, you can take over, remove animated, and let it be keyframe there. So this is what will happen when you play it. When we play it, you see something like this. See, it falls in like that. All right. So if we play it, boom, it falls in. All right. But I don't like this fluid; it's too much. So we're going to reduce the heights of it, and yeah, the height of it, and this as well. Press this. Yeah. Okay, so the fluid is not so much. Okay, so we'll give it some time to fall in. All right, so that is it. We have done our simulation, so we can go back to this and press this to get our simulation back. And like I said, if you adjust anything, press Ctrl A to apply. We adjusted the scale, so and let's press Ctrl A and to apply the scale. Okay, fantastic. Now we're going to play and watch the simulation happen again. But this time around, let's go here. Now watch how this will fall in and how the fluid will interact. So let's press play and watch that happen. So you see it fell inside there. But I think if the bottle container actually fell in much earlier before the fluid simulation happened, right? So we can stop this. You can see it's actually interacting well with the container. It's more better now. So if we play it, stop and play it fast, you see it entered inside while it's falling in. Okay. All right. So you can adjust this simulation, you can adjust this animation by clicking on this and selecting everything by pressing A and move it. Press G to move it down to like move it to say by 25. Okay, so we can move it up to like from 20 to, you know, let's say maybe by 30. Yeah, stop it at 30. Okay, sorry, this thing is actually moving, so let's make it 30. So we can give the water time to have simulated itself, if you get what I mean. So this doesn't move until the water has actually settled down. So by frame 30, the water should have settled down. So let's play it. So let's stop the simulation here, and it stopped at 62. So let's resume it and play it back. It will play fast till 62. So you see the water drops in. Okay, it drops in, then this falls in on it as well. Let's click out so you see what I mean. All right, so we'll go back, water falls in, see that? So it falls in correctly, collides with everything and drops itself in. Okay, fantastic. All right, so that is how you do a fluid simulation for this. If you want to now render or bake this on a higher resolution, you click on the domain objects. Okay, click on domain objects, which is now the fluid, and go back to physics. Click on open the fluid, and you can go ahead and increase this to times 2. Okay, just always increase it times 2. Don't just write any number, just do times 2, which is 128. It becomes better and faster. You see, your system will take some time to calculate it. Maybe because I'm recording my screen, it's a bit slower. Yeah, and when you do that, you are going to go ahead and change this from replay to all. All right, to all. Your fluid box comes back on, and click on this to make sure it's saved in the right place. Press accept, and you just press bake all. Okay, if you click on bake all, it will take some time. You won't be it won't be watching, it won't be happening in your front anymore. It will be happening behind the scene, after which you can, you know, play back, or you can stop the bake by pressing escape. Because it's selected resumable, you can equally press continue baking or free bake to cancel everything. All right, so but that's it. That's if you want to do a high resolution one. Get to this point, press bake all, and it starts to bake. Okay, I'm not to do that now because of time. 64, let's take it back to 64. I'll do that with the next one. So let's go back to wireframe, and now let's delete all this and recreate another scene. Okay, where you can pour some water in a cup, like I promised you guys. Okay, all right, this is okay, this is good. We're going to delete all this, delete all this, and let's pour some water in a cup. All right, press Ctrl A, get a cylinder, take it up, scale it up. So some of you guys that want to do products pre-visualization and all that, you can make this a glass cup. Go to edit mode, go to surface, select the base, and you can press S to scale it down a bit. Okay, and press this place, press E, S, scale it down a little to give you some thickness, because in reality everything has thickness, right? Without thickness your simulations wouldn't work properly. Press 1, okay, press wireframe and press E to extrude it inside, inward, stop it around here, then press S to scale it down. Sorry, put off your proportional editing, press S to scale it down, okay, and that gives it a thickness inside. All right, so this is going to be our cup. Okay, nothing much, nothing crazy. You don't need to have more geometries, but like for the sake of looking tidy, I'll press Ctrl R, add more loop cuts by scrolling my mouse button up, and stop there. Then I'll go ahead and press object, come out from object mode, go to object, and go to shade smooth, right? Why am I not seeing shade smooth? Where is shade smooth, guys? Can you guys shade? Yeah, shade smooth. Okay, and I can go ahead and add subdivision, generate subdivision surface. Yeah, and you see my cup is good. So I can go to edit, make sure that this place is fine, it's okay. Press 3, this. By the way, if this keeps going through the ground and you want to only focus on this, press the slash key on the right side of your keyboard. The slash on the right number side of your keyboard. There's a slash key there. Press it. It separates it out so you can work on it on its own. Okay. Press E, S, scale it in, E, S, scale it in, E, S, scale it in. Okay. You can do the same thing for the guy here. If you press this, the wireframe, you see the guy that you actually, this top guy that you extruded in, press ES, scale it in, ES, scale it in, ES, scale it in as well, and ES, scale it in. All right, press this, so you see that it looks better. And for him as well, I think, at least I think you need to equally press R to give it a loop cut, bring it inside the inner one, give it the inner one a loop cut, not the outer one. Yeah, then add more loop cuts to it as well so it looks more smooth. Okay, all right, so it looks more smooth. If you press tab, come out of there, you see it looks more smooth now, right? Let's press the slash key again to come back to the real world. All right, so this is a quick thingy, a quick glass cup. If we want to place it on the body, on the table, just press this /, click on this bottom surface, go to object, select set origin to 3D cursor. All right, click on slash again. Now if we go to these magnets, click on these magnets. Remember you selected it to face project. Okay, face project is fine. Then what will drag it down, it stays on top of the table. Okay, that's how you snap it to the table. The magnet snaps it to the table automatically. Okay, then click on it to go off. All right, so everything is all set. So we need to introduce something that will be pouring water into this cup. So let's press Shift A, get a UV sphere, take it up, press S to scale it down. All right, and make sure you position it just above the cup. If you press 7, you can look at it from the top. All right, and position it above the cup, bring it down, and yeah, so this will introduce water into your scene. Now when you go ahead and press object, go to quick effects, go to quick liquid. All right, Now, the liquid simulation, all these things you can create it yourself, but it's a faster way of creating it, okay? By going to Quick, you can create a box yourself, go to physics and apply all this and make it a domain and all that. So increase this domain so that it actually accommodates the cup. Press 1 and scale it up. All right, bring it down. Okay, bring it down just to be at the base of the cup. So in case there's anyone that is peeling off, it falls on the domain. And scale it to the x-axis a bit. Press 3. Scale it on the y-axis as well. Yeah, and that's okay. Change this. If you go to physics, it's already selected fluid. Change the flow behavior to inflow. All right, inflow, and press A to apply scale. All right, I think it's now too small, so increase it, scale it up a little bit more, and press A to apply scale. All right, then this as well, press A to apply scale for it, and press A to apply scale for this. All right, then make this, go to here, go to physics, go to fluid, and go to make this an effector. All right, an effector, it's fine. I don't know why it's too long. You can make this, no, not make it a planar, it's not a planar. It's an effector, and make it sample substates. Sampling substeps is how many steps it has to take to calculate this. All right, it's not supposed to be that long. Let's press Ctrl A, apply scale. Oh, okay, sorry. Each time we apply the scale, it actually takes it down. Okay, so do not apply scale for this. Press Shift Z, Shift Z, Shift Z, and Shift Z, Shift Z, and Shift Z. So don't apply scale for this. Now applying scale means that, by the way, we have to put off this. We don't need animations. Come here, press X on the keyframe and delete the keyframe. Applying scale means that it has to be 1 1 1. Everything has to be rounded off to 1. Okay, now this one as well, delete all this, delete this, and yeah, this is not 1 1 1. So press Ctrl A, apply scale, and makes all the scale back to 1. This one, the scale is up to 1 as well. So what we come here, add fluid, add effector, is a collision. It calculates it better, and yeah, the domain, everything is good. Now while we go ahead and go to the domain, let's leave it at 32 so we can see if it's working properly or not. I will come down here and make this to 100, just like the last time. Click on it's resumable, so you can pause and start. And when we play, yeah, you see what I'm saying. So we don't want this. All right, so we've got it working again. I had to figure out what the problem was, and so right now we just had to move the domain up a little bit. So we'll click on this and make this an inflow. All right, let me correct this. I will make this an inflow, but we'll realize that if you move the domain downwards, little downwards like this, it starts to simulate below that. So the domain doesn't want to, you don't move the domain so below. Okay, so it starts to have this other separate fluid thing going on here. So just move it back to the top position to cut it off. Okay, move it back to the top, just a little bit up under the glass cup. All right, that cuts it off. Okay, so when you simulate, it should work properly now. All right, and I'm running this at a 64 level simulation, okay, resolution. Okay, and so right now it's pouring the water. We can see it as the particles. You always have to test your simulation first as a particle to make sure it's working well. is pouring it, but is missing out the cup. Okay, so what you do is you select the cup, go to effector, make the cup an effector. All right, and what thing you notice again is that sometimes this does not work automatically, so you watch and see if it really interacts with the cup or not. All right, so when we watch it and we go through and we see, we don't want to be testing this out at 32 because the higher resolution the simulation is, the better the physics or the interaction will be. So you can see it's passing through the cup. Some of it is entering, some of it is passing through. Okay, it's not perfect. So all you need to do is you go back, select the cup again, and increase surface thickness. All right, increase surface thickness for the cup, make it up to 0.5. That adds thickness, that compensates for the thickness that we added for the cup. Okay, so when we play it again, when we simulate again, we'll see what happens. So you see it currently interacts with the cup right now because we have actually compensated 0.5 for the thickness that we added while modeling the cup. Okay, all right, fantastic guys. So now it's working properly. So what we need to do is we can now go ahead and click on the domain, and we've added liquid. We'll go ahead and add under the liquid, go ahead and add mesh under the liquid. You have to select this, go ahead and add mesh. All right, so we can now see the liquid for itself come out of wireframe, and we can now see the liquid for what it is. So when we press play, we can now go ahead and see the liquid pour into the cup. Okay, then after this, I'm going to go ahead and simulate a little higher resolution of it. I'll pause the tutorial, simulate something a little bit higher res, and play back when it's done higher res, so you can see how to actually simulate it by yourself if you want to do that. Okay, so you see it's pouring inside a cup, although some of it is still spilling out. Okay, some of it is still spilling out through the cup. It's fine. If you still want to fix that, I'll show you what you do. So this actually spelled out, it means it passed through the cup, and you don't want this to be your situation. So let's stop this and watch this. Normally you can see it's going through the cup. When we play back, you see it's boom, some of them came out right while going through. So if you want to fix this, what you do is you select the cup and increase the sampling sub steps. This is for how many frames that your CPU has to compute, right? Has to calculate for the physics collision. How many frames does it account for? Right now it was 0, but now it's going to be adding extra frames while it's accounting for the calculations. Okay, it gives more work on your computer, but it's generally corrects any slight spillage, so that's when we're actually having a collision, because all these things are all calculations, right? So when it's calculating for all collisions, it doesn't miss out on any spots that makes your thing to spill out. All right, so by increasing that to 1, you see if it still spills out, no problem, it still spills out, fine, right? No problem, it's fine. You increase it to 2. Okay, take it, don't jump over like that and make it 3, but don't make it so high, because like I said, is your computer calculation. Click on the liquid itself, the liquid ball itself, and you equally increase subsampling as well. Okay, because this will help for anything that's moving fast. So make it like 4, and let's play again and watch. So see what happened there. Okay, seems like it's not been affected by the calculations. It's not been affected by that. I think it's from the thickness of the cup. Okay, so let's make these things go back to let's leave it at 1. and this one leave it at 3. Then go back to the thickness of the cup and make it, 0.55, that is 0.55, to account for extra thickness. So I think it actually skipped out, a thickness, like it didn't calculate very well for the thickness, surface thickness of the cup. So just add an extra 0.5 to the calculation and we'll see. All right, look at that. Okay, we'll do that again. Let's make this 0.6, and we'll do that again. If it still happens, then we know it's not from the thickness, then it's from the resolution of the water. All right, if we increase the resolution of the water, the more resolution it is, the better the calculations overall. All right, so the resolutions actually helps with the calculations. That's why I start simulate a higher res after this, so you can see. So I'll stop it at 6. I won't take it more than 6, so it doesn't have extra thing happening there. All right, okay, so the rest of it is fine. It's just that spillage. All right, so in that case, let's just go back to point 7. Okay, 0.65, 0.65. All right, then we just have to go ahead and click on the domain and make this one, not 128. Okay, 128. Okay, let's make it 128. Then we'll come back to it once it's done. I have to go in here and cache file. Come in here, change this to 100. Click on this and delete all this formal thing there. Accept. Okay, and we're going to change this from replay to all. All right, and click on resumable, and we'll go ahead and we'll bake. All right, click on bake all, and we'll get back to it once it's done baking. Okay. All right, so we've resumed the bake. So the bake is done, but I went ahead to increase the resolution to 256, and the bake is done right now, but I had to stop it at 73, so I'll reduce this to 73. Okay, so the bake is done, and we can now see with the, well, by the way, 256 I increased it. That doesn't make any, it just makes it very much high resolution. 128 was very fine to fix the spillage that we are getting out. I just had to increase it to 256. I can go ahead and hide the cube if I wanted, but okay, this fair. Yeah, so you can see the actual simulation right here. You see, so this is your fluid simulation. There's no spillage from outside the container. All right, so you can see that. Okay, so it pours the whole thing inside the water, inside the cup, and yeah, so the collision is properly done. Everything is working perfectly. Right, so that is your fluid simulation. This is how you pour water in the cup. There's no spillage anywhere. If you go to the wireframe, you see that. You see what we mean? So if we play it back, you see it pours itself into the cup, and it's actually takes account of the collisions at the inner thickness of the cup. Perfectly done. All right, so this is how you do your fluid simulation. And if you wanted this to be like a tap, you can model a tap and put this sphere in the mouth of the tap. All right, so it looks like the tap is actually the one pouring the water in the cup, and that's how you do all that kind of fluid simulation animations that you love so much. So everything is done properly. The collisions are done properly. Everything is well. The final thing I'll just do for you guys is to just give it a glass material so that you can see through it and you know, you have an idea of what to do. So the cup, let's click on this look development, look dev or viewport shading, and I'm going to, oh, this already has a glass material to it. I'll click on material, click on this, on new material, and we, you know how we do it, we actually go ahead and split our screen. Come here, go to shader editor, press N to close this side panel, scroll forward and go to transmission and make this 1. Take it all the way to 1. That gives it a glass material there, but make this roughness to 0.0 0.03, you know, and so that's is the way it is. Then because we are using we're still here, we're not in the full complete render, we just want to see how it looks like. We can go to here, change this from blend mode opaque to alpha blend, or change it to alpha hashed. Okay, and you can now go ahead and come to here, select ambient occlusion, select screen space reflections, and change this to refraction. All right, okay, so this is going to be refracting, and this is how you get a glass. But if we need to take a look at it in cycles, I can click on cycles and would go ahead and change this to the viewports, and you see, change this to GPU, and now we can see the water thing. If we want, you can click on this and change the, click on this color, go to environment, texture, go to open and search for your HDR environments. Okay, let me use the HDR field. Okay, HDR field. This HDR is a 360 degrees image that you can use to light your scene. You can get it from HDRI Haven. HDRI means high dynamic range image. Okay, high dynamic range image. So you can get it online. Well, there are a lot of free sites like HDRI Haven and so many other sites that will give it to you for free. So you can use that to see through, and you see this is your glass cup and this is water pouring in, and you can change the color of the water. It's the same glass texture I'm using. You can press home and this comes up. So automatically, if you simulate liquid, it will give you this glass texture for water, of which you can still do the same thing we did here. We can go ahead and select all this and, you know, delete it, and still press Shift A, go to shader, go to principled BSDF, all right, and connect it to here to the surface, and go to transmission and make it all the way to 1 and reduce roughness to 0.0, you know, 1, or as much as you can, and you still get the same glass look, right? But you can come here and maybe you want to pour a red wine, make it red, and now you have a red wine in a glass container, right? So this is how you do that. So you can view it by, you can change this to EV. If you still want to take a look at it in EV, you can press this to EV, and you notice what is going on here. There's actually no see-through. You can come in here and I don't want to waste much time on this, but you know, you can press ray trace refraction and it sees through. Okay, and that's how you get that done in EV. All right, just for you to see through what's going on, and that might not be very accurate, but yeah, that's how you do that. That's how you do that. Okay, Yeah. So guys, this is it. This is how you do a fluid simulation. You can let it be in cycles so you can see it properly. You can click on denoiser if you want to denoise your stuff for cycles so that it doesn't get so noisy at times. So you can do that. So this is your water simulation or your fluid simulation. And nice talking to you guys. And if you want to make this environment to go off, go to film, under render, under this, go to film and go to transparent, and the environment disappears so you can focus on your stuff. It only gives you the lighting and doesn't affect your environment. So all right, this is the end of the tutorial. So this is fluid simulation, and I believe you enjoyed the tutorial and believe you can use this to achieve a lot of other things. You want to be creative, guys. Be creative with your simulations. And if you have any questions or anything pertaining that, you can ask, and always come back to the channel. The next tutorial will be looking at the smoke and fire simulations. Okay, smoke and fire simulations will be the next tutorial. So always come back for the next tutorial, and we're going to be handling that very, very well. These are all basic tutorials. Later on, after this series, we'll go into normal advanced tutorials. Have a lovely day, guys. Bye.